Hi all. So here's another example dealing with correlation and regression, but this one's in MyStatLab. So in this problem, we are using someone's systolic blood pressure to predict their diastolic blood pressure, which is Y. So the first thing we want to do is that we're asked if there is sufficient evidence to conclude if there is a linear correlation between the two variables. So the null hypothesis would be always for correlation, rho is equal to 0. So the alternative in this case is rho is not equal to 0. So that's C. We check our answer. And now we need to do a scatter plot. And to do that, we don't actually have to type the values into StatCrunch yourself. If you see this little icon right here or button, you can click it and we can push open in StatCrunch and it automatically brings up StatCrunch for us. It'll bring it up. Let's make this wider. So here's StatCrunch, and we want the scatter plot. So we go to Stat, Regression, Simple Linear. Our X is systolic. Our Y is diastolic. And if we remember hypothesis testing, slope equals to 0 is the same as testing correlation. So we have slope equals to 0, and then our alternative is slope is not equal to 0. And then we just want to find the fitted line plot. And you can do the in this case, we don't need to do the predicted values because it doesn't ask that. So we put compute and we page over for the correlations because that's what we want to see. And we want to compare this scatter plot to the answers. So let's look here. Our extreme value is out here. We have our extreme observation, but it looks like there's one observation that's about 80 for diastolic, and we have 122. So let's go back over. And this one appears to look like it may be correct, but the interval is around 0. So the scales are different in this case. But we're going to look for 120. We're looking for 120 and 80. That's not right. And then 120 and 80. This one appears correct. So we push C. That was correct. And then we want the linear correlation coefficient R. So we go back to our StatCrunch, sorry. Go over, and the correlation coefficient was 0.803 because it says round to 3 decimal places. So 0.803. Yep, that's right. Check our answer. That's right. And our t-statistic. That is over at the parameter estimates and slope. So we'll look at our slope, and that's going to be right here. And our p-value associated is right next to it. So we have 4.265. I think it says round to 3 places. So we do that. 4.26. 4.265. Check our answer, and that's correct. And then our p-value associated with that was 0.0017. So rounded 3 decimal places, so it's 0.002. Check answer, and that's right. Okay, and then remember our rejection region is 0.05, so because the p-value is 0.002, that means it's less than 0.05. Therefore, there is sufficient evidence to support the claim that there is a linear correlation between these two. So check answer. And that's it. And then if you haven't already, there's a written example posted as well. So check that out.